Welcome to the EV Zone. Every week, the EV world is filled with breakthroughs, surprises, and new insights. But today, we're tackling one of the biggest frustrations EV drivers face. Why does your EV lose so much range in winter, and what are heat pumps actually doing to fix it? If you've ever watched your EV drop 20, 30, even 40% of its range the moment temperatures fall, don't worry, you're not imagining it, and you're definitely not alone. Today we're breaking down the real reasons behind winter range loss, and we're going to show you exactly how modern heat pumps are transforming cold weather driving. In this video, we will cover the following 6 topics. Section 1. The real science behind winter range loss. Section 2. How batteries behave in cold temperatures. Section 3. Why cabin heating drains your battery fast. Section 4. How EV heat pumps solve these problems. Section 5. Real-world winter testing from popular EVs. Section 6. The future of cold climate EV performance. If this sounds good and it's something you'd want to watch, stick around as we break the news. With that said, let's dive in. Video disclaimer. Before we dive into the topic of EV range loss and heat pump technology, please note that this video is presented purely as an EV advancement news update. The images shown are for illustrative purposes only and have no affiliation with the company or the brand. We're simply sharing verified testing data and industry insights. For more information, please visit official manufacturer websites and independent winter testing sources. Find sources links in the video description. Section 1. The real science behind winter range loss. Here's the truth. Cold weather affects EVs in 2 major ways: chemical and thermal. Most people only talk about one of them. Today we're talking about both because together they explain the entire winter range mystery. Chemical loss inside the battery. Lithium-ion batteries slow down in the cold. Chemical reactions move slower. Internal resistance increases. The battery becomes less efficient, meaning less usable energy. Reduced regenerative braking, lower peak power output, more resistance during acceleration. Even before you heat the cabin, your EV simply holds less usable energy in winter. This accounts for 10-20% of winter range loss alone. Thermal loss, heating the cabin. This is the big one. Unlike petrol cars, EVs produce almost no waste heat, so the cabin heater must generate heat from the battery, usually using resistive heating. A resistive heater can draw 3 kilowatts, 5 kilowatts, sometimes 7 kilowatts or more. That is like plugging in a small oven and running it while driving. This is why winter range drops so dramatically. Section 2. How batteries behave in cold temperatures. A cold battery is like a stiff muscle. It needs to warm up before it performs well. In winter, charging slows down, regenerative braking is limited, efficiency falls. Power delivery softens. Battery management systems protect the cells by throttling performance. Your car may show reduced regen dots, your range estimate drops, and your battery refuses to fast charge until it warms up. This is why thermal management is so important and why heat pumps play a crucial role. Section 3. Why cabin heating drains your battery fast. People underestimate this part. In a petrol car, the engine is a giant heater. In an EV, the battery is not. So a resistive heater has one job: burn electricity to create heat. And when it's freezing outside, it needs a lot of electricity. On a winter drive, heating can consume more energy than driving. HVAC can reduce range by 30-40%. Short trips are the worst because the heater must warm the cabin from scratch every time. This is why winter range loss feels so dramatic. But here's where heat pumps step in. Section 4. How heat pumps solve these problems. Heat pumps don't create heat, they move heat. They extract heat from outside air, the motor, the battery, power electronics, even the inverter, and reuse that heat to warm the cabin and warm the battery. This is dramatically more efficient. How much more efficient? A resistive heater has a COP of 1 unit of electricity equals 1 unit of heat. A heat pump can have a COP of 3. 1 unit of electricity is 2 to 3 units of heat, meaning less energy wasted, more energy left for driving, less winter range loss. This is the single biggest improvement to winter EV performance since lithium-ion batteries themselves. Heat pumps also warm the battery more efficiently. A warm battery charges faster, maintains capacity, improves regen, delivers more power, reduces internal resistance. The entire EV becomes more efficient when the battery is warm. Heat pumps help make that happen with less energy. Section 5. Real-world winter testing brand results. Let's look at real numbers from actual winter testing. These tests come from a mix of EV owners, independent agencies, cold weather research centers, manufacturer data, and the pattern is consistent. Tesla, Model 3 and Model Y. Range loss without heat pump, 30-40% range loss with heat pump, 15-25% Hyundai Ioniq, 5-6 and Kia EV6, range loss without heat pump, 25-35% range loss with heat pump, 10-20% Hyundai and Kia have exceptional thermal systems. Nissan Ariya, range improvement 12-22% depending on temperature. Volkswagen ID4, ID5, Enyaq, improvement 8-15%, noticeable difference on longer trips. Chinese EVs, BYD, NIO, Geely, some of the best cold climate performers. Their heat pumps often deliver 20-30% range improvement, especially with advanced refrigerants. The bottom line, heat pumps consistently reduce winter range loss, but the exact benefit depends on the vehicle's thermal system. Section 6. The future of cold climate EV performance. The next chapter in this story is even more exciting. EV heat pumps are evolving fast. 1. Propane-based refrigerants R290. This is the next big step. Benefits: works in much colder environments, higher efficiency, lower environmental impact. ZF's new ThermaS heat pump shows 15% more range at 7 degrees, up to 30% more range at 25 degrees. This is real progress. 1. Integrated thermal loops. Future EVs will share heat between a battery, cabin or motor, inverter, charger. This will slash winter energy consumption even further. 1. Predictive heating using AI EVs will soon pre-warm batteries based on your route, reduce heating load using intelligent airflow, store heat for later use, prioritize heating depending on driving style. This will make winter range loss much less noticeable. Now I want to hear from you, because real-world experience is everything when it comes to EV ownership, especially in winter. How much range does your EV lose when the temperature drops? Is it 10%, 20%, 40%? Does it depend on the model, the battery size, the type of driving, or where you live? Have you driven with or without a heat pump? If your car has a heat pump, did you notice a big difference in cabin heat coming on faster, less range loss, or better performance on long winter trips? If your EV doesn't have one, how do you manage winter driving? Preheating, heated seats, slower speeds? Do you think heat pumps should be standard on every EV? Some drivers say yes, absolutely, because they make winter range so much better. Others say no, because they add cost, they can be less effective in extreme cold, and resistive heaters can be enough in mild climates. Your experience matters, because real drivers and future buyers read the comments. So tell me, what EV do you drive? How does winter affect your range? If you were designing the perfect EV, what kind of heating system would you choose? Drop your thoughts below. Your real-world feedback helps thousands of EV owners make better decisions. What's next? We're just getting started. In the next few EV Zone deep dives, we're unpacking some of the biggest questions and upcoming tech in the EV world. New heat pump architectures coming in 2025. Automakers are redesigning their thermal systems from scratch. We'll look at Toyota's new two-stage heat pump, Hyundai Kia's next-gen vapor injection systems, Tesla's rumored Octo Valve 2.0 concepts, and what these mean for real-world winter range. Why do some EVs still not have heat pumps? Is it cost, supply chain, or is there more to the story? We'll break down the engineering trade-offs, how region-specific regulations affect the decision, what it means for resale value and long-term ownership. Winter tires, the hidden range thief or savior. Winter tires can increase traction but also increase rolling resistance. We'll test all-season versus winter tires versus all-weather real data on highway versus city range impact. Whether eco-winter tires are worth it. The truth about battery preconditioning myths. Does preconditioning really cost 5 to 10% of your battery? Is it ever okay to skip? Does it matter if you're using LFP versus NCA NCM chemistry? We'll break down the data and show exactly when preconditioning saves range and when it wastes it. Are 40% winter range gains actually coming between heat pump redesigns, silicon anodes, 800V architectures, and immersion cooling? Are we on the verge of EVs that lose only 5-10% in cold weather instead of 30-50%? We'll examine what's real and what's hype, what's coming in 2025-2028, which automakers are ahead, and who's falling behind. So, what do you think of this video? We'd love to hear your thoughts. Share them in the comments section below. At EV Zone, we believe open discussions can lead to great discoveries. Here, we consider both sides of the coin and welcome all viewpoints to explore new possibilities. In the search for greener energy options, we encourage our audience to join in and share their ideas. Each of us has unique creative contributions to offer, so if you have something to share, reach out to us and we'll create a video to share it with our audience. Thank you for joining us on this enlightening journey through the world of EVs. Whether you're an enthusiast or simply curious about the future of transportation, stay tuned for more exciting content on EV Zone. Don't forget to subscribe, comment, like, and share this video to support our channel. Thanks for watching, and see you in the next video.